Hello students, today it's time for going over your practice problems 2.4. Should have them completed. Now you're checking them to make sure you understand what's going on. Number 26, we were to find the slope using the points given, and our formula for slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or the other way we think about it, delta y over delta x. So in this case it would be 36 grams minus 18 grams. Doesn't matter which one we call point 1 and point 2. In this case I'm calling this one point 2 and this one point 1. Just make sure you do them same order. And then we got 24 cubic centimeters minus 12 cubic centimeters. So 36 minus 18 is 18 grams. 24 minus 12, 12 cubic centimeters. If you don't want to pull out a calculator, could just reduce this down. 6 goes into 3, and 2. So it ends up being 1.5. Looks like it's a good number of sig figs. Gram per centimeter cubed. Here's our slope. Part B, same formula. Now time to find the slope. So m equals y2 minus y1 over x2 minus x1. And I like to take the bigger one and use it as 0.2. 28.16 grams minus 19.03 grams divided by 25.6 cubic centimeters, 17.3 cubic centimeters. Do a little subtraction, and 28 minus 19 would be 9.13 grams divided by 8.3 cubic centimeters. Calculator work now. 9.13 divided by 8.3, and we get 1.1 on the calculator. I think I'll keep 3 sig figs, looking at what we started with. 3 sig figs, so 1.10 grams per cubic centimeters. That's our slope. Might recognize these units as units of density. And one more slope problem, another one here. M equals y2 minus y1 over x2 minus x1. This time I'll call this point 2, this point 1. So I got 205.8 meters minus 147 meters divided by 21 seconds minus 15 seconds equals, it's like 58.8, subtracting the first one, and divide by 6 seconds. 58.8 on the calculator divided by 6 equals like 9.8. Well, the calculators tell me looks like 2 sig figs is good, meters per second. This time we got a speed as our slope. And one more. Call this one 0.2, this one 0.1. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 equals 75 minus 18.75. I put my degrees Celsius in there. And we're dividing that by, it'll be 75 kilojoules minus 55 kilojoules. Bottom part's pretty easy to subtract. 75 minus 55 is just 20. Top part, I will type in my calculator. 75 minus 18.75. 56.25 degrees Celsius. Yeah, we got to divide that by the 20. And looks like we get to keep 2 sig figs. We'll go 2.8 degrees Celsius per kilojoule is our slope. Number 27, which units would you use to measure the following quantity? Amount of water you drink in minutes. Now remember, we're in SI. Don't try to write down things like quarts or gallons or pounds. SI, amount of water you drink each day. A liter would be good. Milliliter would be good. Could also do something like a cubic centimeter. Any of those would be good. Liter, milliliter, better. But cubic centimeter would work. Distance from New York to San Francisco. Kilometers would be about the only thing that really makes good sense. Mass of an apple could be grams. Could go kilograms. Grams would probably be the best one. But kilograms would be okay. And how does adding the prefix to an kilo to an SI unit? So kilo just means 1,000. So it multiplies it by 1,000. And units for density. The SI system, we could use something like grams per milliliter, or grams per cubic centimeter are the most common ones we used. And are they base units or derived units? Definitely derived units. Is a combination of base units. Number 30 is important for a quarterback on a football team to be more accurate or more precise. Yeah, so we want to be accurate. Is more important. And one of the reasons here, because the target changes each time. So the quarterback wouldn't want to throw it to the same place every time, which would be precise. The 31. Student takes 3 mass measurements. Measurements have error of a 0.2, 0.38, 0.47. What information we need to determine if these are accurate or precise. And we would need the accepted value. So accepted value has to be known to find accuracy, and for precision, if we had, depending on the accepted value, we might consider these precise or we might not. Just depends on what kind of a number we're using. But if only when we want to find precision and accuracy, we always have to know the accepted value. And if we want to convert minutes to hours, what conversion factor? So if we're going 2 hours, that means we need hours on top. And we're getting from minutes, we want minutes on bottom, and you should know 1 hour is 60 minutes. And 33, what kind of a graph would you use for the following data? The segments of population to vote for a certain candidate. Probably a bar graph would be good. We're looking at different types of things. But a circle graph would probably work too. Many times, if a bar graph will work, a circle graph will too. And I'd probably do the bar graph here. Average monthly temperatures of 2 cities. I think a bar graph would be best there. Line graph might be kind of okay, but if we do a line graph, we're looking at monthly temperatures. The points in between the dots really don't mean anything, so bar graph best here. Amount of fat in 3 different kinds of tater chips. Potato chips. Definitely a bar graph would be good. Percent by mass. See that word percent always, you can do a circle graph. Score on math quizzes during a year. Maybe a bar graph would be good. Effect of a hormone on tadpole graph or a line graph would be good. The difference between using a bar graph and a line graph has to do if we have what I explained on notes PowerPoint, whether it's discrete data or continuous data. So that takes care of this group of practice problems. Hopefully you understand all this and you'll be able to answer these type of questions on a quiz. So that's it for now.